Hello everyone! Today we will learn about orthonormal basis. A set of vectors in Rn is an orthonormal set if it is an orthogonal set of unit vectors. An orthonormal basis for a subspace W or Rn is a basis of W that is an orthonormal set. In other words, we can say that an orthogonal set in which each vector is a unit vector is called orthonormal. A vector V subspace of capital V is called a unit vector if the length of vector V equals to 1. An orthonormal set of vectors is an orthogonal set of unit vectors. Let U1, U2 until Un be an orthonormal set, then Ui, Uj equals to Uij equals to 1 where I is equal to j and 0 where I is not equal to j. A basis B of an inner product space V is called an orthonormal basis if B is also an orthonormal set. Let S equals to U1, U2 until Un be an orthonormal set in V. Then, S is an orthonormal basis of span U1, U2 until Un. Note that an orthonormal set is linearly independent. If S is a basis, then it is called an orthogonal basis or an orthonormal basis, respectively. Therefore, a set S of vectors in an inner product space V is called orthogonal if every pair of vectors in S is orthogonal. If, in addition, each vector in the set is a unit vector, then S is called orthonormal. Therefore, a set S of vectors in an inner product space V is called orthogonal if every pair of vectors in S is orthogonal. If, in addition, each vector in the set is a unit vector, then S is called orthonormal. For S equals to V1, V2 until Vn, this definition has the form shown that first, Vi, Vj equals to 0, where I is not equal to j. Second, the length of vector Vi is equals to 1, where I equal to 1, 2 until n. If V1, V2 until Vn is an orthogonal basis, then the orthonormal basis or set is given by V. Now, let's look on examples. Let's proceed to the example question of orthogonal basis. Let W be a subspace of R4 with the basis 1, 0, 1, 1 and 0, 1, 1, 1. Find an orthonormal basis of W. So, how to solve this kind of question? Firstly, let V1 equals to 1, 0, 1, 1 and V2 equals to 0, 1, 1, 1. Note that they are not orthogonal as the dot product is V1 dot V2 equals to 2 and not equal to 0. Let us first find an orthogonal basis for W by the Gram-Schmidt orthogonalization process. Now, let W1 equals to V1. Next, let W2 equals to V2 plus A V1, where A is a scalar to be determined so that W1 dot W2 will equal 0. As W1 and W2 is orthogonal, we have 0 equals to W1 dot W2 and equals to V1 dot V2 plus A V1. We will get 0 equals to V1 dot V2 plus A V1 dot V1. We will get 0 equals to 2 plus 3A. We get 2 because the product of V1 dot V2 is 2. While the product of V1 dot V1 equals to 3 and times with the scalar A. And that's why we get 0 equals to 2 plus 3A. By making A as the subject, it follows that A equal to -2/3, and we can substitute A into the equation of W2. Now, to avoid fractions in our computation, let us consider 3W2 instead of W2. Note that the scaling does not change the orthogonality. When we times the whole equation with 3, the fraction will disappear and we will get 3W2 equals to 3 1011.-2 0111 equals to -2 3 1 1. Thus, the set W1, 3W2 is an orthogonal basis for W. However, the length of these vectors are not 1. As we see, the length of vector W1 is equals to surd3 and 3W2 is equals to surd15. Now it suffices to normalize the vectors W2, 3W2 to obtain an orthonormal basis. Therefore, the set 1 over surd3 1011 and 1 over surd15 0111 is an orthonormal basis for W. And we're done!
Hello guys, shall we proceed to the example? Okay, what the question asks from us? Let me see. Find the coordinate with the respect to orthonormal basis. How to solve it? Aha! I know it! From the question, we are given V1 and V2 where the P is equal to V1 and V2. First, we find for V1 squared is equal to 1, also for V2 squared equal to 1. So, we have to find V1 times V2. The answer is 0. From that, we know that B is basis for R squared. So, we are given X, where to find the coordinate is use formula XB. And then, we just substitute the formula and we get the answer. Okay guys, we are done.
So next, we will have a look at a proving problem in the next example. Example 3. Show either W equal to V1, V2 is an orthonormal set in R power of 3 or not. Given the question as below. V1 equal to 1 over square root 5, 2 over square root 5, 0. And V2 equal to -1 over square root 4, 1 over 4, 3 over square root 4. And here is the solution. To show that W equal to V1, V2 is an orthonormal set in R power of 3, first we have to show that V1 times V2 is equal to 0. Here you can see, when we do the calculation for V1 times V2, we will get the answer is 0. And here it's shown that V1 times V2 is equal to 0. So tick. Next, we have to show that V1 times V1 and V2 times V2 is equal to 1. And here is, when V1 times V1, we will get 1. And when V2 times V2, we get 41 over 60. Then, we can conclude that W equal to V1, V2 is not an orthonormal set in R power of 3. since V2 times V2 is not equal to 1. Done! Thank you for watching.